Nice straightforward probability question. Important that you read carefully the question, because in these questions, if you don't read all the information, then you'll be in trouble. If you're not using all the information, you won't be getting anywhere near it. Important thing to realise here is that Mary is entitled to 2 jumps and she clears 1.7. So she either does it on her first jump, in which case the probability that she does that is P, or she fails on her first jump and then manages on the second jump. So the important things here are the and the ors. So what we have is that the operator for the or, so she either jumps on her first jump or does its second jump, in which case if it's a second jump she fails on the first bit, 1 minus P, because P is the probability that she gets it, multiplied by P. In other words, she fails, then and passes. And the question tells me that that is 0.64. And fairly obviously what I've got here is a quadratic in P. And so if I expand this out, I'm going to quite happily get P plus P minus P squared is equal to 0.64. And I personally prefer my quadratics to be positive square term, so therefore P squared minus 2P plus 0.64 is equal to 0. You've always got to get that equals 0 in when you're solving quadratics. Now there is no way in this world that you are going to factorize P squared minus 2P plus 0.64. And we all know that the Trusty White calculator, the ClassWiz, does the job for you, but when you're under exam conditions, you must show the technique that you're using. So therefore you have got to use the formula. You don't have to quote the formula, but it's not a bad idea. If you use a formula, make sure you use it properly. So I'm saying that P is 2 plus or minus 2 squared minus 4 times 1 times 0.64, all divided by 2. And as soon as I've done that, then I can go on to use my calculator. All right, but I've got to show the technique that I'm using. Now this gives me, as with all quadratics will, it will give me 2 answers. And the answers you'll get from your calculator is that P is 8/5, or that P is 2/5. It would be good to realize, of course, that the probability scale is 0 to 1, and therefore P can't be equal to 8/5 because 1.6 is not a good probability, and therefore P is 2/5 or 0.4, 2/5 tups in 2/5 or 0.4. That's why I went to write that. Doesn't matter whether you write it as a fraction or a decimal, but there's my explicit answer. That's a relatively straightforward probability question. Nice, easy 4 marks. Go for it. Now, the important thing is that I want both athletes to be field athletes, but I'm given that the first athlete is a male. Okay, so the probability I want, okay, is nice and easy. I want that the first person I choose is a male and a field athlete, and given that, I know that the area there is 22. Of course, this one's the same. He can die. So the probability that the first one is male is 9 out of the 22. And the second athlete that I choose, again, I've got this and or coming in, and to multiplication I'm going to look for here. Remember that I've chosen an athlete and I haven't replaced it, so it is conditional probability. So I've nicked one from here. So there's only 8 male athletes left, but I'm not interested in whether it's a male athlete or a female athlete, as long as it is a field athlete. So this time my total probability there is 12 out of the remaining number of athletes. So really what I need to know in the first place is how many athletes I had altogether. Okay, 13 plus 9 gives me 22, which I've already done, plus 7 gives me 9, plus 4 gives me 33. So I had 33, but I've taken one off it, so I've only got 32. So the probability I want is that the first athlete is a field athlete and a male, and the second athlete is a field athlete. It doesn't matter whether it's male or female, hence the 12 out of 32, because I've taken one off already. Okay, quick bit of multiplication going on here. Doesn't really matter. Your calculator will do it quite merrily for you. Gives you a probability of 27 over 176. And I haven't got the decimal equivalent for that because I wouldn't bother calculating it that way. I personally, because of the age I am, usually give my probabilities as fractions. There is another way of doing it, but think simple is usually best.
I agree with my colleague that the way that he did it is the best way in this particular situation. It's relatively straightforward, but given that conditional probability can be a tricky one, then it's worth having a little look at this in terms of conditional probability. So if we can sort of translate the question, it's saying that there are 2 events. The first event is that the athlete is male, and we want to know whether they're a field athlete or not, the probability. So that's going to be the probability that we have a field athlete, given that we're only selecting from the males. The second probability is a new situation. I'm going to go over the top here a bit, and I'm going to put the new numbers in, because we know for the second one that we actually have one fewer of the male field athletes, because we're looking at that as the probability for the first event. So for the second event, we simply want to know whether they are a field athlete. Now, by the way, to avoid confusion, notice that I'm using F for the field and M for the male. In that case, if there was a question with female, I'd have to do FE or something like that, and T for track. But just watch out for that little potential problem. So, going back to the probabilities, the probability of a field athlete, given that they're male, well, we can just look across the column and we can see that there's 22 in total, so we get 9 out of 22. But we could write this instead as the probability of field and male divided by the probability of male. And this would give us 9 out of 33 for the top fraction divided by 22 over 33. Either way, for the second probability, we're looking at the total number of field athletes, which is now 12, divided by the total number of athletes, which is 32. And of course, that will give us what we got before, which was 27 over 176, or if you want it as a decimal, 0.1534.